Hi everyone, this is Sam Christensen in Physics 341 for a description of the T1, T2, and T2 star features in the pulsed NMR lab. And so let's talk about T2 star first. So if we have all of these protons initially aligned with the magnetic field, and then we activate an A pulse of 90 degrees, it flips them all perpendicular with the initial field, creating the maximum signal in the detector, and then we can observe them after turning it off, slowly drifting down back to alignment over time. And the time that it takes for them to get from this first alignment back down to here is our T2 star. Next, let's talk about T2. If we turn on an A pulse again of 90 degrees and flip them up here, we notice, and then turn it off again, we notice that due to discrepancies in the magnetic field, that as they float down, the magnetic moments of the protons start to drift apart a little bit. They're not just all on top of each other. And so a way that we can try to correct for this is by activating B pulses of 180 degrees at different intervals. And so this means that as the protons start to drift down back towards alignment and drift apart, they'll be flipped back over 180 degrees, and they'll be a little bit closer to aligned to their previous alignment. However, it's important to note that the magnetization will get lower and lower in amplitude, because when they're flipped 180 degrees, they move closer together again, but they still are a little bit spread. And so over time, this spread will become such that the magnetization eventually goes to zero. And that's why we see the echoes eventually decreasing in amplitude exponentially and going to zero. But T2 represents the time that it takes for all of these protons, magnetic moments, to drift apart like that. Now finally, T1, we start with an A pulse of 90 degrees, an A pulse of 180 degrees, and that will flip all of our protons 180 degrees in the field facing here, and then we turn on a B pulse of 90 degrees, and that'll flip all of the protons that were anti-aligned with the field upright into the maximum detector, the formation that gives us the maximum detector output. And then these, after we turn the signals off, will slowly start to drift back down towards the initial alignment. And the time that it takes for all of these to float back to that initial alignment is called T1. And the reason that this T1 is important is because it tells us how many of the protons were initially aligned with the field. Because if you think about it, if they're initially aligned with the field and they get flipped anti-aligned with the field and then flipped 90 degrees back, they would be perfectly aligned in the detector, but only protons that were perfectly aligned would do this. And so T1 gives us a good measure of how many protons were initially aligned with the field. All right, thank you very much.